Hey explorers, welcome back to Virtual MOSI. This is again our Earth Week, and today what we have for you is two exciting activities that you can do at home all about weathering and erosion. Those are two important factors in the health of our soil. So let's go over those definitions real quick in case you've never heard them or it's been a while. Weathering is the breaking down of rock, either physically or chemically. So you can smash the rock, or some sort of chemical process can happen where it breaks down. And I wanted to point out that physically breaking down a rock, that includes organically. So roots breaking through the soil or breaking through the rock can cause weathering. Erosion, on the other hand, instead of just the breaking down of rock, refers to the carrying away of the rock particles. So the big difference between these two definitions is where the process is happening. Weathering is happening in one place, breaking down something, and erosion is actually taking those particles somewhere else. So now that you know those definitions, let's go over our first experiment. And it has to do with weathering. So what you're going to need for this experiment is some water, some vinegar, a couple cups, some Play-Doh or clay, something like that, and sugar cubes. Now what I've done here is I've put roughly the same amount of sugar cubes, I counted them out, into each cup. You see that okay? And on top, I've put a layer of Play-Doh, just so you can see what that looks like. I left one of them empty, so you're just gonna put them right on top and seal up any holes that you might have around the rim. We want it to be pressing right against the edges of the cup. There we go. And make sure that when you do this, you leave a little bit of room on the top because you're gonna be pouring in a liquid. So what this experiment is for us is determining what is going to cause weathering faster. Is it going to be physical weathering, like just pouring in water so we can dissolve the sugar cubes? Or is it going to be chemical weathering, where we actually break it down with an acid? Remember what we said, we did a whole lesson on acids and bases last week. If you haven't seen it, definitely go back and give it a watch. Okay, so now that you have your sugar cubes and your Play-Doh, you're gonna take a toothpick or a fork or similar, and you're gonna poke a few holes in the top of that layer. The Play-Doh represents that top layer of rock or soil on the earth, and the sugar cubes represent the rock underneath. Now in Florida, we have largely a limestone bedrock underneath the surface, and limestone actually breaks down relatively easily. And when you do this, try to make sure you're giving roughly the same amount of holes. We don't want to have our experiment ruined by changing too many things or too many variables. And now we're going to pour however much you want. I'm going to pour 2 ounces of vinegar into one of them. Or you can do some other measurement if you like, just make sure that they're the same. We're gonna pour that in. You see the bubbles coming up on top? That means that it's actually leaking down below the surface, and you can see it start to fill. And I'm going to pour 2 ounces of water in the other cup. Let that get down there and dissolve. Okay, and if you need to, you can label them so you don't forget which is what. So I'm going to label this one V for vinegar and W for water, and that's going to take a second. So we will come back to this experiment after we do our next activity. So that's weathering, everything breaking down in place. This is erosion, how particles actually get moved away. And it really depends on the type of rock or the type of soil that you're dealing with. So what you're gonna need for this activity is some 2-liter bottles, or just bottles of the same size. If you wanna use smaller plastic bottles, that's just fine. And you're going to need to take scissors and cut out a hole in the side of the bottle here. I've already done that for you guys. You can see I took away those pieces. And you're gonna wanna leave the spout intact and enough room on the side so things don't spill out. And I've done that 3 different times. If you wanna do more than that, that's fine as well. And I have some different types of soil. You're gonna need something like sand. This is just plain potting soil. This is just rocks. Can you see that okay? Some small pebbles. And right here, I went and grabbed some grass that I dug up outside with my shovel. Now, this experiment works a little bit better if you can be patient enough to grow your own plants, your own grass, your own whatever you want to put in there. It just lets the roots go through your entire experiment. But if you're in a rush like I am, you can just grab some from outside. But do not take it from your parents' lawn without asking. All right, other things you might need for this experiment include some yarn, optionally, some cups. I used the yarn to make these little hanging cup baskets that you can put on the ends of each of these bottles. Okay. Now we're going to see how the material in each of these bottles impacts the erosion of the soil inside. They all have a little bit of dirt. This one is mostly just dirt and sand. This one I've filled up with dirt and mulch, just like that, little wood chips. And this one, of course, as you can see, is filled up with grass, and it's got a nice root system all the way down there. There's a few pebbles as well. And I've got some water. Now again, when we do our experiment, we want to make sure we're keeping the variables as consistent as possible. The only independent variable we have in this experiment, or the thing that we're changing, is the type of soil. The control variables, or the things we're keeping the same, include the type of bottle, the size of the bottle, the amount of filling, the amount of water we're going to pour in, and we are going to measure our dependent variable. We are going to qualitatively see which water ends up the clearest. All right. Now that we've fully explained the experiment, let's do it. All right, I'm gonna pour, I just wanted to be able to measure how much I'm gonna pour in there. So I'm gonna pour in about 6 ounces of water. You can do half a cup, whatever you like. But make sure that you don't put more water in than your cup can actually hold. So maybe to be safe, I'm actually just gonna put in half a cup of water. There we go. Keep it the same. Okay, now I'm gonna come around to this side. If you can come up with some sort of contraption to hold them at an angle, that's great. We haven't had a chance to do that today, so I'm just gonna tip it. So I'll pour in half a cup of water, and I'm going to try to tilt them all at the same angle. I'm gonna hold the bottom of the cup and see what kind of discharge we get there. Ooh. All right, so we got quite a lot of water, and it is very dark. A lot of the soil washed away with it. We had an awful lot of erosion. All right, so let's try it again. Again, I'm gonna do 4 ounces of water. And this time I'm going to pour it into our second 2-liter bottle here, the one that has all the mulch and soil. And I'll try to tip it at about the same angle and see what comes out. All right. So very nice. We got quite a lot more water in this one, which was a surprise to me, but it does look a lot clearer. We had some of the mulch, it looks like, preventing some erosion from happening. And now let's do our last bottle, the one with the grass in it. And again, the same amount of water. And I'm gonna pour it onto the grass here and see how much comes out. And if so, what kind of color it is. All right. So again, we had quite a lot of water come out. Maybe I tilted it a little more than I meant to. And as we kind of let it settle, we're gonna see how much dirt actually came out with this water. Right now, to me, these two are looking pretty much the same, but maybe this one is a teeny tiny bit clearer. It looks like it's settling much faster than the other one. Maybe it has less particles in it. We'd have to wait and see. Let's go back and take a look at our experiment again with the water and the vinegar, because it's had a bit of a chance To me, it looks roughly like maybe the vinegar one is breaking down slightly faster, or they're kind of the same. But you can see those sugar cubes have now dissolved quite a bit. And you'll notice that underneath our kind of Play-Doh surface here, we now have an empty cavity. Right now it's filled with water, but if that water were to leak out, we would have an empty space or a cave. So this is why Florida has so many riddled caves and sinkholes under the surface, because that limestone breaks down very easily from the weathering. Pretty cool there. Okay, there's one more variation of this experiment that I want to try with you guys. And I'm gonna get rid of these, pour them in my extra bucket that I have on the side. And because it is Earth Week, not only did I want to show you how erosion and weathering works, but also how erosion can be impacted by pollution. So let me rinse out these cups here. So this time we're going to keep the experiment exactly the same, but instead of just pouring in water, I am going to add some food dye, which will represent for us pollution. And we'll see if there's any difference in that. So I chose red for my food dye, but whatever you've got. You really don't need a lot, just a couple of drops. Looks like this one has not been used before. Open that up for you guys. And definitely, if you have any questions, as always, feel free to shoot them down at the bottom. Okay.
We have one question from Michelle.
Yes.
How come the first one had the least water come out?
How come the first one had the least water come out? That is a good question, Michelle. If I had to guess, I would say that the soil there was so much more soil compared to mulch or grass that the soil just kind of absorbed a lot of that water, which is not actually a result I expected to happen. Sometimes when you do experiments, you're going to be even surprise yourself. So,
We also had a comment from Brian. The soda bottles make him think about an indoor herb garden.
An indoor herb garden, yes, definitely. So I said before, if you can be patient and grow your own plants in the bottles, then your experiment is going to work a little better. It's going to be a little more true to life. So if you want to grow herbs or something like that in there and have it serve a use after your experiment, go for it. All right, let's try it again. I'm going to pour red water in this one, and let's see if we do actually get more water come out this time. And I'm going to try to keep the angle that I pour it consistent. And it looks like this one is just taking a little longer to drain. I'm noticing, if we can bring the camera up to the top, I'm noticing that a lot of this water in the first bottle is kind of resting on the surface. It's not easily being absorbed by the soil, which is another thing to consider. And that might be part of the reason we didn't have as much come out before. If you've ever had your yard flood in a big rainstorm, or if you've ever driven on a road, if you were an adult, right after a rainstorm and it's just been absolutely flooded, less absorption is taking place. Okay, so again, I'm gonna pour the same amount. See what comes out here. Try to keep it at the same amount of angle, and this time I'm trying to keep it do it for roughly the same amount of time as well, because that might be a variable that I inadvertently changed. All right, and our last one. Okay, do we notice much of a difference between those? I feel like maybe it's a factor of the soil, but I feel like there's more red in this one than in that one. Let's see if there's any noticeable difference with our final bottle. Okay. All right, well, in this case, it looks roughly the same to me. We can let it settle a little bit. But what should be happening in this bottle, if you do it at home, and it hasn't been as noticeable in this experiment today, but the roots from the grass and the plants that I have in here should actually be holding a lot more of the water, a lot more of the soil, and it should be filtering out some of that pollution for us. So maybe as we let that sit, and if you do that at home, it'll become more apparent. Try it out, see if you get the same result as me, see if you get a different result. Because remember, in science, we need to have repetition and replication in order for our results to be considered valid. That means I have to do the experiment multiple times, repetition, and other people need to do the same experiment and see that they've gotten similar results, replication, in order for us to consider our results to be valid. All right, any final questions before we finish up for the day?
We had a question from Jose about the board in the background.
The board in the background, yes. I'm glad you noticed this. This is something we're going to be doing more tomorrow. Tomorrow for Earth Week, it is Earth Day, and we are doing an activity all about reusing and upcycling different materials. So stay tuned for that. I think it'll be a lot of fun. Anything else before we sign off? All right. These are two excellent examples of experiments you can try at home. They don't take a lot of material. You don't need to go out and buy anything special if you can find it outside. Let us know what you find and enjoy. And as always, keep discovering.